Okay, so we're going to do comparing surface area and volume. Okay, so we have our rectangular prism here. And on this rectangular prism, we can find two very different things. I can find the surface area of this prism, or I can find the volume of the prism. They're going to give me actually different numbers. Okay, but I want to explain what the difference is. Now, volume is the amount of space inside of something, or the amount of space something takes up. So, in other words, if you take a look, we have these blocks here, right? And now what I'm going to do is I'm going to move this so we can see them a little better. Alright, so we've moved our rectangular prism here. And I want you guys to look at this. So, what I'm going to do is I'm going to try to take this literally. Do you see that this is 1, 2, 3, 4 across? So we're going to say that's 4 units. Okay? 4 units. And what I'm actually going to do is I'm going to draw some lines up and down so that you can see that these units are split. Okay, so 1, 2, 3. So we have 1, 2, 3, 4. See how we have 4 columns there? Okay. And what I'm going to do is I'm also going to say that the depth or the width of this is 2 units. So I'm going to split it in half. Okay. So I'm going to split this guy in half. So he's been split into 2 columns. And I'm just going to quickly do the back as well. Okay, the back as well just kind of falls on the roughly the same length here. Okay, we're going to say it's kind of overlaps a bit. Okay, so we're splitting all of this into our columns. Okay, so we have, it's a little hard to see, but we have 4 in the front, 2 on the side, 4 in the back, 4, and 2 on this side. Okay, so we split this into columns. And finally, what we're going to do is we're going to say that our height here is 1, 2, 3, oh, again 4. Okay, so this is also 4 units. And we're going to split this again into 4 units. So here's across in the front, and in the front. Okay, and then when we go this way, you can kind of see it here. Okay, I guess I shouldn't have done the ones in the back, but the idea of this, oh, it also goes across the top too. And there's these columns like this. There you go. Okay. So what we've done here, you see how I've split into many different cubes? Each of these cubes, okay, represents 1 unit cubed. That's how much volume it takes up. So what we're actually trying to calculate is the number of cubes inside of this. Okay, so there's going to be a lot. There's a whole bunch through the middle also. And if we were to split these all up, there's going to be all kinds of rows and columns, right? So an idea, I'll show you that if we were to split it. Okay, so what we've done for the above guy is I've actually split these. Okay, if you notice, I have 1, 2, 3, 4 across the bottom. 1, 2, 3, 4. So the length and the height are 4. But I've actually only done this one 1 wide, and this one is 1 wide. Okay, now if I put them both together. Now, if I were to actually move these together, okay, they would actually be 2 units wide, okay, just like what we had above here. We had 2 units wide. So think of this like I took a knife and I split this right down the middle, okay, because we want to see exactly how many blocks are involved in this, okay. So altogether, this is the same as this guy here. So to figure out how many blocks we have, well, we're going to go 1, 2, 3, 4 times 1, 2, 3, 4, right? So how many blocks are there? Yeah, 16 blocks. And what about on the other one? 1, 2, 3, 4 by 1, 2, 3, 4. How many blocks? 16. So, if we were to put them together into the shape we had above, right? How many blocks would there be altogether? Yeah, so the whole shape has 32 blocks, right? So this is what volume is. We're trying to find out how many blocks are involved. So, what I'm going to do here, remember volume is our length times our width times our height. Okay, so what is our length in this one? What about our width? And our height? Alright, so let's multiply these. What's 4 times 2? 8. Okay, so 8. We've got to multiply by 4 again after. What's 8 times 4? 32. 32 units. Or, just like we had below, It is 32 blocks, right? So if you notice, volume is just the amount of space something takes up, okay? But surface area is very different. I'm going to do it on the next page. Surface area gives us a different idea of a shape. Okay, so now we're going to go over surface area of the same thing, okay? Remember this was 4 units. Oops. We said this was 2 units. And this was 4 units in height. Okay, so exact same shape, but surface area is actually the area of each face. So we have to talk about the amount of faces. We have a face in the front and one in the back. We have a face on the bottom and one on the top. And we have a face on the right and one on the left. How many faces are there altogether? Yeah, so we have 6 faces. Okay, that's already very important for surface area. We have 6 faces here. Now, have you guys done nets or webs of a shape? Yeah. When you kind of lay it out flat, like a net? So we're going to quickly make a net of this shape, okay? A net of this shape, we're going to need a lot of room for it. It's going to be 4 wide, right? So here's one of the faces. And then 4 down, 1, 2, 3, 4. So this is one face. And I'm going to have to move it over. Right, so let's keep going. So we'll say that's the front face of it, right? Now we said there are 6 faces. Okay, so that's the front face. The top is 2 by 4. So the next one, the next face is still going to be 4 wide, but it's only going to be 2 long. Okay? So think of this as the top of it. So we've done the front face, which was 4 by 4. The top face, which was 4 by 2. What's the dimensions of the back face? Yeah, that's right. It's 4 by 4 again. Okay. So again, we go 1, 2, 3, 4 by 4. And then what about our bottom face here? Not 1, but yeah, 2 by 4. Okay. Extend a little farther, and the bottom face is 2 by 4. Okay, I have 4 faces. What am I missing? 2 side faces. Okay, so what is this side face? What's the measurement of it? Yeah, that's right. It's 4 by 2 again. So I'm going to attach it to the side. Let's say it was attached to the top, like we opened up the top. So here will be the top. It's 1, 2, 3, 4 by 2. Okay. And the other one, is it going to be the same? Yeah. Okay. So here's what's important. This is like our net of that shape. So we can count our faces, right? This is the front, we'll call it. Front and back, because those two are important. Then we're going to say top and bottom. Here's our top and bottom. And we'll call this the right one and the left. Okay, so do you see how we have 6 faces? Our goal is to actually find out the area of each of these faces, so all the space it takes up. Okay? So I have to find the area of all the faces and add them together. So I'm going to quickly write out what their dimensions were. This was 4 by 4, right? How long was this? 2. How wide was it? 4. How about this one? How wide? 4. And how tall? 2. How about this guy? 4 by 4, yeah. And the bottom is 2 by 4. And of course, let's do this one here, by 4. So let's focus one at a time when going through the area of this, okay? So I'll highlight the first one we're going to do. We're going to do the front, okay? So what would the area of the front be? Yeah, we're going to say AF, we'll call it area of the front, is, we know length times width, and the length is 4, and the width is 4, so the area was 16 units squared. So that's the area of the front. Next one we'll do is we'll do the back, okay? Just so you see now, is there going to be a difference between the front and the back? No, it's going to be the exact same thing. So I'm just going to write underneath area of B for back is the exact same, 16 units. Okay, so we got that. I'm doing green here. We'll do the area of the top. What are the dimensions for the area of the top?
4 by 2.
Okay, so I'll say A of t is equal to 4 by 2. So what is our area?
8 units squared.
8 units squared. Good. What about the area of the bottom?
4 by 2.
Is it the same?
Yeah.
So what is it going to be?
8 units squared.
Good. So area of bottom is another 8 units squared. And then finally, we'll do these in green again. What are the left and right going to be?
4 by 2.
Yeah, similar to any of the other ones?
Yeah. Similar to the bottom.
Similar to the bottom and to the top. So what do we have? We have area of the right is going to be how many units?
8 units squared.
Yep. And area of the left?
8 units squared.
Okay. Now, the reason they were telling you to multiply by 2 when doing surface area is because if you notice there's doubles of everything. The front, if we just took the front and multiplied by 2, we would have got the front and the back. The top, if we just took the area of the top and multiplied by 2, we would have got top and bottom. And if we took the right and multiplied by 2, we would have got right and left. So that's why they tell you to find the area of 1 and just multiply by 2. Okay? So now what I'm going to do, oopsie, not what I want. Let's go page width again. We're going to find out the surface area. So how much space this actually takes up. Which means we have to add everything together. So the surface area is actually equal to the area of the front plus the area of the back plus what else?
The top and bottom.
Area of the top,
Left
area of the bottom, area of the left, and area of the right. A lot of areas, right? So what was the area of the front? Remember?
16.
And of the back?
15.
Okay. So instead of writing 16 plus 16, what should we do?
Multiply by 2.
Yeah, so let's just write 1 in because they said to multiply by 2. 16 times 2. And then we got to add, what's the area of the top?
8.
Okay, and to find the area of the top and the bottom, what will we do?
Multiply by 2.
Good. And finally we add, what's the area of the right?
8.
And to find area of the right and left?
Multiply by 2.
Good. Okay, so we have that. What is 16 times 2?
32.
And 2 times 8?
16.
And 2 times 8?
16.
Okay, and now here's the tough part. 32 plus 16 plus 16.
That's 64.
Very good. 64 what?
4 units squared.
Okay, units squared. Okay, so this is very big difference. I'm going to bring up both pages now. Get both of them in here. I'm just going to scroll down a little on this one. So for the area of this, first of all, oops, units cubed. Okay, when we're finding area, volume, what is our end? We're in units what?
Units
Cubed, because we're talking about 3 dimensions here. But in surface area, we're in units
Units
squared. And did we get the same number? No, we didn't get the same number. It just so happened to be double, but that won't always be the case. Okay, so it's very different between surface area and volume. Okay, does that make sense?
Yeah.
Okay. Okay, they have another question added here, and they wanted to know. Call question 2 is the area of the base, okay, times the height, the same as the volume for a rectangular prism. Okay, so we already know a volume of a rectangular prism. I'm going to quickly put up a picture again. Okay, so we have our rectangular prism, and we know the volume is what? Length times width times height. Okay, so that's our volume. Volume is length times width times height. Okay. What is the area of the base?
4 units.
Oh, okay. So, you're giving me the length. So yeah, you're right. This is 4. This is 2. This is 4 again. Okay, we'll use the same numbers. Units. But how would I find the area of the base? The area of base, they're just going to be looking for
it just be 4 units? Or will it have to be 4 units times 2 units?
That's right. We have to do 4 units times 2 units. They want just this area right here. Okay? They want that area there. So what's 4 units times 2 units going to be?
8 units.
8 units. Okay? So area of the base is equal to length times width. Okay? And the area of the base is 4 by 2, which is 8 units. So what?
8 units
Squared. Good. Now they said, if we just take this base, we'll go to full page view here. Take the area of this base and we multiply it by the height. Will it give us the volume? Well, first of all, let's think about that. The volume is length times width, okay? And area of the base is length times width. If I just multiply by height, so I decide to add in an h here, is that going to be equal to the volume? Yeah, it is. It's going to be the exact same thing. But let's talk about why that is, okay? Again, we're gonna split this into blocks. Okay, so I'm going to split this into blocks. Let's say, so here's our first one across. Goes like that. And we have another one goes like that, and another one that goes like this. We're just going to split this, okay? So it looks like we have our columns. Okay. So what we've actually found here, and I'm going to highlight and color it in, is what's the height of one of these?
The height is 4 units.
Well, sorry, of just one of these blocks.
Oh,
1 unit, right? Okay. So one of these blocks is just 1 unit high. Okay. So in terms of volume, what is the volume of one of these blocks?
1 unit squared.
Well, the volume we have to do length times width times the height. So 8 units squared, right? Now, if the height is 4 of them, I would just have to multiply whatever the volume is of this yellow block 4 times this one, times this one, times this one, right? And what is the height in this?
4 units.
4 units. So again, it's the same as the length times the width times the height. So whenever you're finding the volume of a prism, it's got to be a prism, okay? Volume of a prism. You can find the area of a face, okay? And that's what they did. The area of the base is also just the area of one of the faces, and then multiply it by the height, okay? So in this one, if we take a look at it, remember our area of a base was 8 units. So let's just kind of keep going here. 8 units. What's the height in this one?
4 units.
Okay, so let's say we're multiplying by the height. What's the volume of the, or what's the area of the base times the height going to be?
2 units squared.
Okay. Now, because we're in volume, we don't use squared anymore.
Oh,
Cubed. Okay. And what if we had done it this way? The length was 4 times 2 times 4. What we have gotten?
2 units cubed.
So it ends up being the exact same. So whether we find the base and then multiply the height, or we just multiply length times width times height, we get the exact same thing. So our last question here we're going to look at here is, say 3. How do the dimensions of a rectangular prism with the same volume, so 2 rectangular prisms with the same volume, but they have different surface areas, how do they compare? So you actually made quite a few, and we decided to take the one with the largest surface area and the smallest surface area. So we're actually going to draw these out. First of all, what was the dimensions of the one with the least surface area? So least
3 centimeters. Oh, the length would be 3 centimeters, the width 2 centimeters, and the height 2 centimeters.
So length was 3, width was 2, and height was 2. Okay, and they're all centimeters. And what about greatest?
The length was 12 centimeters.
The length was
12 centimeters.
Mhm.
And the width was 1 centimeter.
Mhm.
And height 1 centimeter.
Okay. What were the surface areas in the end?
For the leaf was 32 square. Centimeters square.
Centimeters squared.
And the other one was 50 centimeters square.
Oh yeah, big difference, eh? Okay. I'm going to actually draw these 2 shapes. I'll give us a quick second. Okay, so we drew them by units, and we tried to put it to scale so you could see the difference. This one was 3 by 2 by 2. We'll say each of these little squares is a centimeter. And this one was 12 centimeters by 1 centimeter by 1 centimeter. Okay? So, there's quite a difference between these. Describe some of the things you see as different here.
That one is smaller than that one.
Yeah, we definitely know the surface area is smaller, but the volume's the same.
The volume.
Yeah, remember we discussed the volume is going to be the same between these. Because if we do 3 times 2 times 2, that gives us 12.
And
And if we do 12 times 1 times 1, that gives us 12 centimeters cubed. Okay. Now, what I wanted to draw your guys' attention to is I want you guys to notice what shape is our smallest one coming closest to? A cube. Yeah, very good observation. It's coming closest to a cube, right? And actually what happens is the closer and closer we get to a cube, the smaller the surface area is going to be for the same volume. Okay? So if this was even a more even one, if we could have done it by, say, like 8 and 2 by 2 by 2, a cube would have been the most efficient shape. The longer we make something, the more inefficient it becomes. So the closer we get to a cube or square faces, the smaller the surface area is, or it's called more efficient, okay? Because this was close to a cube. So let's say close to a cube shape. And the other one was far from a cube shape. Okay, and those are very important things in math, okay? Squares are the most efficient four-sided shape, okay? The only one that's a little better, can you think of it? It'd be really hard. What shape do we use to move places? We're going to move somewhere. Say you're in a car. Cars don't run on squares, right? Circles. Circle. If we found something like, do you know what a three-dimensional circle is called? A sphere. If we had the volume of a sphere, and I can't really draw a sphere on here, I'm not that talented, but if we had a sphere, and its volume was 12 centimeters, its surface area would be even smaller than a cube. It's the one that'd be a little better, okay? But for what you guys are going to do, the cube will be the most efficient one, okay?